wait, where should I go? Okay, we are back. I'm gonna do another question, which is which set of forces of forces never produce never produce zero acceleration zero acceleration or force. So when we talk about zero acceleration, we are talking about the magnitude. And so let's look at our options. The first option is 10 Newton, 10 Newton, and 20 Newton. The second option is 6 Newton, 8 Newton, and 10 Newton. The third option is 7 Newton, 12 Newton, and 20 Newton. And the fourth option is 1 Newton, 2 Newton, and 3 Newton. So the answer is it's gonna be C, but you might have a question, why is it C? So to understand why this is C, first of all, I will give you a short answer, then I will give you a long answer. So the short answer is basically to find this, the sum of the sum of um, other the sum of other vectors then other um, vectors so sum of other vectors other than other than largest um, is um, if is okay wait let me think of my English. Sum of other vectors other than the largest other than the largest other than the largest vector if is greater than the largest vector then the largest vector in terms of magnitude only, then um, zero vector is um, then resultant of zero magnitude is possible. So let's read it again because I wrote this, I'm not sure if it's correct. So the sum of other vectors other than the largest vector if is greater than the largest vector in terms of magnitude only, then the resultant of zero magnitude is possible in some case. In some case. So which means that it is not always possible, but in some case it might be, or it is certain to be possible. So if you're like me, you have no idea what this is trying to say. So let's look at each example and show you why it is possible. So this is basically the gist of it. And to understand this, we are going to take each one. So let's take the first one, which is 10 Newton, 10 Newton, and 20 Newton. So let's try to make it so that the force has a magnitude of 0 Newton. So I will purposefully try to do that. So to do that, let's say this is this is 10 Newtons. So let's make this white and let's make this thicker. I don't think we have to make him white for this case. So let's take two, since there are two 10 Newton vectors and there is 120 Newton vectors. So if you look at the cases, the following cases I can see. If everything is in the same direction, everyone is pointing in the same direction, obviously the answer is gonna be 40, sorry, answer is gonna be 40 newtons. So since this length is 40, it's gonna be 40 newtons. But since we exactly want it to have 0, if I change this so that it has an opposite direction, so if I change this and it has opposite direction, this vector, so let's make this white, is cancelled out by this thing right over here. So it's exactly cancelled out, um, which means we will get 0. So I think this is pretty clear. So think about it. Here there is a 10 Newton force, here there is a 10 Newton force, and here there is a 20 Newton force. And if there is an object somewhere over here, this will just be as saying as 20 Newton force. So here is 20 Newton force, here is 20 Newton force, and as a result, the net force is 0 newtons. So the net force is 0 newtons, which means that the acceleration is also 0 meter per second square. So I'm just taking a look at the magnitude, and that's why I'm not referring to the direction in any of the cases. Since these vectors can be in any direction, so as long as they're in this format, and this is the only case where there will be zero acceleration or zero force. So let's look at the second case, which is B, which is 6 Newton, 8 newtons, and 10 newtons. So 6 Newton, 8 Newton, and 10 Newton. So before we look at this, we will actually have to look at this statement to understand why we are talking about this. So sum of other vectors other than the largest vector, so the sum will be of 6 and 8, if is greater than the largest vector in terms of magnitude only. So 6 plus 8 is, let's do some quick math. What is 6 plus 8? So 6 plus 6 is 12, so you add 2, that will be 14, and 14 is greater than 10, which means there is a possible case where the resultant is 0. So let's go back to this case and try it this way, so that we try to make it everything is in like that. So let's say this is 6, this is 8, and this is 8, and this is 10. So this is 10. So if everything is in the same direction, obviously it's not gonna be 0. So let's rotate the biggest vector to the other side. Now let's look at these two vectors. If I just let's make this one white so that we know which we are trying to cancel. So if we add them in the same direction, so let's do this, move this over here, and if we try to put them in the same direction, this is 6 Newton, this is 8 Newton, and this is 10 newtons. So this portion is 10 newtons, and this portion is 6 plus 8, which is 14 newtons. And if you look here, this force is greater than this force, so the net resultant actually becomes 4 newtons in this direction, but we don't care about the direction right now, we are only looking at the magnitude. So in order, so you might think that there is no possible case to have 0 force, but you will be wrong, because there is obviously, this is not the only way to add these vectors. So now we're gonna try another way to add them vectors. So let's copy this vector over here, and let's move it so that so we actually want this vector to be in opposite side. So if I rotate this, and let's make it red, since this will actually be red. So if I have a vector which is 10 newtons, so if this vector is 10 newtons and this white vector is also 10 newtons, then obviously the net resultant is gonna be 0 newtons. So this will be 0 newtons in terms of magnitude. But the question is exactly how do we get 0 vector? And the answer is actually pretty simple. You just change the angle. So you just change the angle between these. So if I change the angle, so let's say this is our 8 Newton, I change the angle. The size might have changed, but just think of it as not changing. And I move this vector to, so we have to create a parallelogram. So let's think about it so that it becomes a perfect parallelogram. So there, and copy that over here. Looks like it's not exactly matching, so let's make it, move it over there, and let's move it like this. So let's see if it's parallel. Yep, it's parallel. And let's make these two lines, I don't know what to say. Let's not make it arrows, let's make it dotted lines, and no arrows please. So as you can see, this is still 8 newtons, like this force is still acting 8 newtons, and this force is still acting 6 newtons, but the resultant of this 6 newton force and this 8 newton force leads to 10 newtons, and it leads to 10 newtons in a certain angle only, and you can obviously find what this angle is by using the resultant formula. So the formula will be r equals square root of a square plus b square plus 2ab cos theta, where the symbols have the usual meaning that I taught you. So r will be the magnitude of resultant, and a will be the magnitude of a vector, and b will be the magnitude of another vector, and theta will be the angle between the a and b, so vector a and b. So in this case, obviously the r, which is a resultant, it'll be 10 newtons, so I will just write 10 in this case, and e will be 8, so let's just say it's 8 newton, and let's say b is 6, so you can just add the value of each of this term, and you only have the unknown variable, which is going to be theta, so you can obviously find theta. So you can find theta from this, so and you can find this, and you can know what it is. So this might be a small question for you if you want to try it out, and this is the reason why this will be 0. So obviously this case did not work for this one, but doing it like this worked, and how can we be sure that it's always going to work? And to understand that, we are going to actually see this one, which does not produce 0, and this is the 7th one, so 7, 12 and 20. So option C, which is 7 newton and 12 newton and 20 newton. So let's go back and check it out. Yep, it's 7, 12 and 20. So now let's show you why this is. So if I add 7 and 12, so first of all, going by this definition, this might be quite confusing if you think about it, but hope it's not. So let's just write a very simple version of this. So sum of other must be greater or equal to largest. Oh, I think greater or equal to, so greater than or equal to, so greater or equal to. So I think this is more accurate. So greater or equal to the. So sum of others must be equal to or greater than the largest. And when I'm talking about the sum of other, we are talking about other than the largest vector, and the largest, we are talking about the largest vector, and we are only taking the magnitude in both cases. So even when we are adding, we are only taking the magnitude, and when we are talking about the largest, we are only taking in terms of magnitude as well. So let's look over here. If you just add them up, so 7 plus 12, I don't know how to do the quick maths, so let's think about it. If this were 8, this will be 20, so it will be 19, and 19 is the one less than 20. So obvious question that might be in your mind is, why is it not possible? So basically, let's do the thing. So let's say this is 20 newton. Let's make it white, and let's make it a lot more thicker, and let's think of a case where the force will be maximum. So let's say this is 20 newtons. Now let's just add the 7 and 12 newtons. First of all, let's do them in the same direction for easy sake. So let's say this is 12 and this is 7. Then there are a few cases. If they are all in the same direction, obviously it's not going to be 0, so we have to have them at least in the opposite direction. So let's try to keep them in opposite direction, then we will look at what happens. So if I keep them in opposite direction, it will be 19, so it will be like this. Even so this is 7 newton and this is 12 newton. So even if I took the maximum, this is the maximum, just adding them will be the maximum, it only leads me with 90 newtons, whereas here there is 20 newtons. So I think you can see the problem right over here. Even if I took the largest possible resultant of the smaller vectors, it will always lead me with something less than the other vector. So this will lead us with 1 newton in this direction, but obviously direction does not matter right now. We are only trying to look at the magnitude. So this is why this does not work. I think I gave a pretty clear explanation. Since obviously you can take this vector and rotate it in any way you like, from being parallel to being exactly from in the opposite direction. So it can be in 0 degrees to 180 degrees and any other angle in between them, as long as the magnitude stays the same. So I can rotate it, since um, in this question, so a question that you might have is, isn't a vector defined by its uh, defined by its angle and its magnitude, so its direction and its magnitude, and that's right. But in this case we are not given the direction, so it can be any direction, and the question is which of these can never produce. So as you can see, obviously in this case where they are the 6 and 8 newtons are in the same direction, whereas 10 newtons in the opposite direction, it does not produce zero force. But whereas if it is in a certain condition, which is this, it will give us 0 newton, and that special case also has a special angle that you can obviously find. And over here, even if you took the maximum, so if you took something not the maximum, so if you had it in some angle, obviously this will still be less than 20 newtons, since it must be, this is the maximum value, and since the maximum value is still less than the thing, it will not work. Also, let's look at the last one, the D1, which is 1 newton, 2 newton, and 3 newton. I think this one is the most simplest. Now we have understood what we are talking about. So let's just say, let's copy this one. Why not? Let's make this 3 newtons. So let's make this so that this is on 3, and let's make 2 newtons and 1 newton right over here. Let's make it orange. And obviously in this case, if all of them are in the same direction or any other angle, it will not be 0. And obviously in this case it will only be 0 when they are exactly opposing each other, since the maximum value when you add them up is gonna be 3, and 3 will just cancel out this other 3. So this is 1 newton, this is 2 newton, this is 3 newton, and this thing right over here will be 3 newtons, and this will be 3 newtons. So in resultant you will also get 0 newton. So to clarify everything that I've said, since I think this video was a little bit confusing on because I did not explain it pretty well, so let's think about something. If you add, so let's look at the statement first of all. If you add the magnitude of the other vectors except for the largest vector, and it is greater than or equal to the largest vector in terms of magnitude, then it is possible that you have a resultant of 0 magnitude in some case. It's not guaranteed that in every case it will be like that, but in some cases it's definitely possible. But if this condition is not satisfied, in no way in hell it is possible that you can get that 0 vector. So in this case, where the maximum, which is the smallest, except for this one, except for the largest vector in terms of magnitude, if you add up the other vectors, just the magnitude, and it's not greater than the magnitude of the largest vector, and so in no way in hell you will get this. You will get 0 vector. And when we are talking about a 0 vector or 0 acceleration or 0 force, we are talking about 0 in terms of magnitude, so it will be like 0 vector. So we are talking about the 0 vector. And I think I clarified everything that I wanted to say. So I think that's it for today's video. In the next video we are going to do another question. Till then, bye bye.